Energy and entropy. We learned in prior years that energy is conserved. The total amount of energy in a closed system does not change. Also, it is often said that energy is the ability to do work. There is a flaw in this thinking. Consider the case of our rock on top of the cliff, and after it falls, its initial energy is now heat. Does the energy stay constant? Does the ability to do work stay constant? Discuss. If you wanted to drive a stake into the ground, you would need to do work on the stake. If the amount of energy were the same in both cases below, which would you choose to drive the stake into the ground? Dropping the rock from the top of the cliff directly on the stake to drive the stake into the ground, or dropping the rock onto the ground next to the stake and then using the heat released from the rock hitting the ground to drive the stake into the ground? The amount of energy is the same, so if energy is the ability to do work, the answer should be that both would succeed. Would they? It's difficult to efficiently harness energy that's in the form of heat. It's not very efficient for doing work, but it's still energy. Energy is critical to understanding life, but is insufficient. A key missing element is entropy. Entropy is a measure of the amount of energy which has been dispersed, so is not readily available to do work. Note that the energy is not destroyed or reduced, it is dispersed. The energy of a closed system stays constant, but the entropy of a closed system increases with time. The energy in a system disperses, spreads out over time, and becomes less useful for doing work. So the amount of energy available to do work declines with time. Can you use the concepts of energy and entropy to explain what happens when a rock falls off a cliff? The rock is pushed off the edge of the cliff and lands on the ground. What happens to the energy of the system? What happens to the entropy of the system? The energy of the system is conserved, so it is the same before and after it falls and hits the ground. The entropy of the system has increased, since its initial potential energy has been converted into heat, which is dispersed and less able to do work. After the rock has come to rest on the ground, explain in terms of energy and entropy whether the energy in the system could launch the rock to the top of the cliff or not. Why or why not? Discuss. Although the total energy of the system is conserved, much of the energy has become unusable, increasing the entropy of the system. There is no longer enough usable energy to do the work of lifting the rock back to the top of the cliff. It would be impossible to use the dispersed heat to lift the rock. The universe is a closed system. Within the universe, there is a constant amount of energy and a continuously increasing amount of entropy. As a result, there is a continuously decreasing amount of usable energy in the universe. However, there are many open systems within the universe. Within any open system, energy can increase or decrease as long as the energy in its surroundings change in a way that keeps the total energy constant. Likewise, the entropy within any open system can increase or decrease as long as the entropy of its surroundings changes in a way that keeps the total entropy continuously increasing. Life is an open system that depends on the interplay of energy and entropy within its surroundings. Within cells, energy and entropy can increase or decrease as long as those changes are offset by changes in their surroundings that keep energy constant and entropy increasing. This will be true for the chemistry of early Earth, through the first life to today's most complicated ecosystems. These ideas will recur throughout this course.